we have another example of integration, rational function of sine and cosine. Now this time around, we get this integral over here, the integral of dx all over the cosine of x minus sine of x plus 1. Now at first glance, this looks intimidating. Maybe for some this looks intimidating, but actually, once you perform the correct technique of integration, that will be easy. And the technique that we're going to use for today is known as the Z-substitution. Basically, in Z-substitution, you let you let Z to be equal to 1/2 of x over here, or I mean tan of 1/2 of x, and then you let dx, as you can see on this side here, you let dx to be equal to 2dz over 1 plus z squared. And alongside with that, you do the substitution also for the sine of x and cosine of x respectively. And as I've mentioned from the previous video, it's quite easy to remember all of this one, because the numerator terms for each of these are basically just, I'm hoping you can see, it's just 1 plus c squared, 1 plus z squared, 1 plus c squared. So basically, all of them are say having a factor of 1 plus z squared in the denominator. Now once you have this set in your mind, what you're going to do is to simply perform the integration. So over here, this is going to be the integral of dx of over the cosine of x minus sine of x. So the first thing that we're going to do is to substitute based on what we write on the right. Now, of course, the integral will remain. The dx will now be expressed as 2dz, that is all over 1 plus z squared. I'm simply replacing dx and then divided by, I'm also going to replace cosine of x in terms of z, so that will just be 1 minus z squared all over 1 plus z squared. So that's my cosine of x, and minus the sine of x. This expression 2 is simply be 2z all over, of course, 1 plus z squared. As you can see, sine and cosine have the same term, 1 plus z squared, in the denominator. And you have plus 1. Now, if you do inspect whatever is in the integrand, you notice that I'm going to highlight this part here. You got 1 plus z squared and 1 plus z squared. So both of these terms have a common factor. So if you recall from your algebra, if you have a over b, and then you add c over b, if they have the same term, I mean the same denominator, that's simply equal to, you take the denominator and you add whatever terms are on the numerator. So we apply the same thing here. So this will become, I'm just going to erase this one. This will now become, okay. I'm going to deal with the numerator first. So this is just 2dz all over 1 plus z squared. And then the denominator will be, as I've said, we'll just copy 1 plus z squared. And then we add the term 1 and 2. So the first term is 1 minus z squared. And then since this is negative, so plus multiplied by negative will be negative. So we have minus 2z. And this one, we have remaining plus 1 there. Now, we're going to simplify again only the denominator part. So I'm just going to rewrite again the numerator, which is just 1 plus z squared. And on the denominator, if you notice, I can rewrite this one as, I will take my 1 plus z squared as my common denominator for both terms. So if I'm going to do that, I'm simply going to have 1 plus z squared. You divide it by this one, and that is 1, and then you multiply it by the numerator, right? That's how we do in our algebra. So that means to say, this will just become 1 minus z squared minus 2z, because if you recall what I said, if you're taking 1 plus z squared as the common term for these two terms here, what you're going to do is to divide 1 plus z squared over this one, and whatever the quotient of that, is it quotient? Yeah, whatever the quotient of that, you multiply it by the term on the numerator. So that's why 1 plus z squared divided by 1 plus z squared is just 1. So you multiply it by everything on the numerator, which is 1 minus z squared minus 2z. So I'm just going to take that out. And you do the same thing. So 1 plus z squared, you divide it by, of course, this is understood to have 1 over here. Divided by 1. So 1 plus z squared divided by 1 is 1 plus z squared. And you multiply it by the numerator. So 1 plus z squared times 1 will simply result to plus 1 plus z squared. So you simply add the term 1 plus z squared. Now, I'm hoping that your eyes lighten up, because basically some things will simplify. So in this case, you notice that plus z squared on the denominator part and negative z squared will simply cancel out. And then the 1 and the 1 will add up. And also, I'm just going to have this step by step. I know you can already see what's going to happen, but I'm just simply going to take it step by step. Now, I have written here the numerator part, but since the numerator part, this portion over here is divided by the denominator part, the one in green, you have to recall again from your algebra that if you have a over b and then you divide it by c over d, that is equal to having a over b multiplied by the reciprocal of the denominator, in this case d over c. So we're going to utilize this same thing here. So what's going to happen is we get, so of course 2dz over 1 plus z squared, this is this part here. I'm hoping you can see. This is this part here. And so I'm going to divide it by the denominator. So as I've said, we have to take the reciprocal. The reciprocal is 1 plus z squared. I'm going to simplify everything here. If you notice, you got 1. Okay, I'm going to use the pointer. If you notice, you have 1 and 1, so that will add up to 2. And then the remaining terms would be negative 2z. So that's going to be negative 2z. Now, of course, the greatest day in history, this will be cancelled out. And we have a very simple expression now. So this will become the integral of 2dz. That's what's going to remain on the numerator. And on the denominator, I could have 2. We'll have 2 minus 2z. And we want to simplify it further. We got 2dz. I'm going to factor out 2 from the denominator. So what's going to happen to the expression in the denominator? We got 2 times 1 minus z. Alright, so you can see that the constant 2 will cancel out. So our integral now is a very simple integral of dz all over 1 minus z. And we know how to integrate this one. If you remember basic u substitution and integration, I'm going to write it here. You let u be equal to the term on the denominator, which is just 1 minus z. And this is telling you that du is just negative dz, or negative of du is equal to dz. Now we did that in order to integrate this one simply. So remember that your u is 1 minus dz. So the term in the denominator is simply u. That's u. And then according to this one, your dz is just negative du. So you have, I'm going to take out the negative du over u. And we know this to be the very basic form, or this is just equal to, if you can recall, hopefully you can recall, the integral of du all over u is simply the ln of u plus c, since this is an indefinite integral. So this is telling us that this is just negative ln of u plus c. But do not get tempted to stop there, because we did substitution before, so we have to replace u by what we let it earlier to be 1 minus z. So this will become negative ln of 1 minus z. Now, most of the students would stop here and they will just probably get, say, 7 out of 10 because this is not yet the final answer. If you notice, from the very beginning, our terms were actually in terms of x. And if you notice here, you're getting a term of z. So that is telling you that you should supposedly get x terms in terms of x. But then again, the technique that we did is we performed z substitution, where z is equal to tan of 1/2 of x, which is a term in terms of x. So this is telling you then that you have to further substitute z in terms of x. So this will become negative ln of the absolute value of 1 minus z based on what we substituted earlier. This is just equal to the tangent of 1/2 of x. So that means that this will be written as tangent of 1/2 of x. So that's ln of 1 minus z and then plus c. So this is your integral. This is how you solve your integral of dx over cosine of x minus sine x plus 1 using z substitution.